Welcome to Content Security Policy from newbie to advanced. I'm going to try to take you all the way to advanced in just 1 hour. That's a challenge. But let me just know where you are on this scale. So who had heard about Content Security Policy before this week? OK, good. Who has worked with the policy before? Who's worked a lot building from the ground up or doing cool stuff with content security policy? That's good to see. Got some advanced people here. I'm sometimes going to abbreviate it as CSP, because that's shorter. This talk is going to be like when I took this picture. I don't do snorkeling because I like to dive and I don't want that snorkel to be filled with water. I'm also not a scuba diver, so I swim down, I swim up to breathe again. So we're going to touch on something that's a bit complicated, but if you have a background in web technology, yeah, it should be quite easy to reconnect when I'm up to breathe. And that's going to happen quite frequently. So me, I'm a good swimmer. My name is Halvor Sakshaug. I do application security at PG Forsta, a company you probably haven't heard about. Used to work for the Norwegian software company Confirmit. It was merged and acquired, so it changed names. Sometimes I do some writing on the blog, and I'm on Blue Sky. So CSP is about protecting your app in the user's browser against a lot of threats. And yeah, we'll get the details. Why do we want a content security policy? Number one, to protect against cross-site scripting, XSS. That will be the main focus of the talk, and I think most people who are really into CSP will say that that's the main thing, but it's also really hard. But we can also use it to protect against framing, exfiltration, and unwanted sources. Now, this is what the psychologist would call the inner motivations. We also have some outer motivations, audits, pen tests, and clients saying that, well, you should have a CSP. A lot of times they just say you should have a CSP header. They don't really know what should be in it, so that's up to you to decide a lot of times. I think I saw the first such requests 6 to 8 years ago, and ever since it's just been increasing. Every year there's more and more and more. But they still haven't really advanced in kind of what they expect or have been specific. Another reason coming this year, if you have heard about PCI DSS, payments card industry standard, there's a new version coming out or being enforced in April, 1st of April. It's not a joke. It pretty much says that you'll need a CSP or something similar if you are taking credit card payments on a page. So it's from my doctor's office. I thought it was appropriate to put it here. So this talk, I'll start with the more introduction to CSP, with terms and variations, because there is things we just need to know so we understand all the bits of it. I'll give a live demo of how to develop a policy, at least the starting point of it. I'll go into depth in how you prevent XSS. I've answered more than 300 questions on Stack Overflow on CSP. So I'll tell you about some of the gotchas. There is a section for it, but there is also some of them sprinkled around in the presentation. Talk about reporting, and finally, how not to make a policy. So a CSP we typically deliver as a response header, so it's just a string. And it's something it's a policy that we set and deliver to the browser, and the browser will enforce it. And we define different directives, which control different things. So the directives have names. In a lot of places, I'll put that in green so you can more easily see where the different directives start and end and what their names are. And then most of the directives also take sources. Let's just imagine a web page, a very simple web page that we build like your first homepage. Different classes of content, So you put in some different URLs there. In this case, relative URLs, because you load from the same origin. And of course, the way HTML works and the browser works, if you reference some content, it's loaded. Same thing with an external source. And if you have some inline styles and scripts, if you have an image in the data URL, everything will load, because that's how HTML works. Then CSP comes along. And then let's just see if we're really strict and we set default source none, which means pretty much like, yeah, don't accept any sources on this page. So everything changed from green to red because now these things won't load. So that's, of course, too strict. We can change that to self, which is pretty much like the same origin. Now we see that all the relative URLs, which are loaded from the same server, now they will load. So the page will start coming alive. We can expand this policy. Now I added a host. So everything that's on that host, it's a script and a style, they will now load. OK, another thing we can do in the policy, we don't need to let everything go to the default source directive. We can implement a different directive, in this case, style source. That's styles. So now styles are kind of singled out. And we set it to self. So we don't get xyz.com anymore, because when there's a style, the browser will check for style source, and it found style source, so it won't go further and check default source. But then we can set unsafe inline, which will allow all the inline content for styles. So now it's allowed for styles, but not for scripts. And just to show you how it works, we'll remove default source. Now we're only restricting style source. Everything else will just pass, just like the regular HTML case or no CSP case. CSP has 3 levels, which they could also have called versions. I don't know why they didn't. Number 3 is still in draft mode, but it's been for a number of years. Until fairly recently, you would think about compliance with level 2. You don't really need to anymore, because most of the browsers have now caught up. Like Firefox is missing a few details, mostly about reporting. So you can safely only use level 3. Disposition, you can enforce the policy with content security policy, or you can just do report only, like not enforced, with content security policy report only. And why not make it visual? I don't know if you know how the conference web page looks like in and out. I'm going to use that as an example a lot here in this talk. To the left, there's an enforced policy. And the enforced policy is font source none, which means load no fonts whatsoever. And you might recognize this as a Chrome default font, because that's what it's showing when it's not allowed to load any other fonts. So that's what happens, like stuff breaks on your page. And there is also an error in the console when this happens. On the right side, it's content security policy report only. Also font source none, but it looks just like we expect, because it's not enforced. It's just the report only. Normally, you would also add a reporting directive here, so you could actually get the report about this violation. But you can also see it in the console. We get an error, which isn't really an error, but it would be an error if we had enforced it. That's why it says report only. On the beginning of the console error there, it says report only. It does not on this one. In CSP, there are a lot of directives, and the directives go into different classes, except one that doesn't. Because there are also some things that are just thrown into CSP because, yeah, why not? We tried to define something and didn't really take off, so we'll just put it into CSP. Upgrade insecure requests, down there, that's one of them. Means if there is an insecure request, like HTTP, make it secure, HTTPS. Also the iframe sandbox thing. So it's also a directive in CSP. But the main thing here is the fetch directives. That's where we'll focus. That's about the sources on a web page, and that's typically what we want to restrict. But there is, of course, a lot of other cool stuff here. So I talked a bit about the fallbacks and what happened when we had default source and style source. So all the fallbacks, here they are. For instance, if you don't implement worker source in the other class, it will first go to child source. If that isn't implemented, it will go to script source. And if that isn't implemented either, it will go to default source. So like everything here that has, or at least in the fetch, that doesn't have or isn't implemented, it will eventually go to default source. Now, this isn't everything, of course. I've left some space here. So script source and style source, they can be split into elements and attributes. Actually, the specification says don't do this if you don't have a use case for it. But it's really useful in the reports to see, is this an element or an attribute or is another type of element? Now you might wonder, what does fall under the different directives? So I put that up here. The blue are tags and the orange are script constructs. So yeah. I don't expect you to remember. There won't be a test on this. And if there's something new, something which isn't defined today, where would that go? Well, it would most likely be sending or receiving data. And that would be connect source. So if there's something that isn't defined, it will default to connect source. And if that connect source isn't implemented, it will go to default source. And also, experimental directives. There has been like a few directives that have come and go in CSP. These aren't actually part of the draft specification, but they're implemented in Chromium. They're quite cool, but I won't be covering them, unfortunately. Don't have time. So that was the directives, and now the sources. Sources for most of the directives. So the most important ones, self and none. None is kind of easy. It's like an explicit way of making an empty list. Then you have self, which is almost the same origin, but it's not. It's the same origin and upgrades. So if you're on HTTP, it's also HTTPS. And also, if you're on a non-default port, it includes the default port for that scheme. And then you can take host sources. So you can take a host, but you can also add the scheme, you can add the path, or you can add the port, or you can add all of them or more of them. We also have scheme sources. These are very broad. So if you really want to restrict something with your CSP, maybe you shouldn't use them. But in some cases, yeah, it makes sense to use these. And then scripts and styles take some additional sources. You see a lot of things that are called unsafe here. And there's a reason for that, and I'll try to explain it a bit. There is something here, top right, report sample. This will send the 41st characters of a script or style in a violation report, which can be really neat if you need to locate something. So I'll go into a bit more depth on all of these later. So there are different keywords, hashes, nonces, and some other script keywords. I'll come back to them. If you read about CSP, it will seem like you can do this in two ways. You can set it as a response header, or you can set it as a meta tag. Well, the meta tag is more restricted than the response header. And setting it as a meta tag is pretty much like walking out in the streets of Oslo today without winter shoes and proper clothing. You'll only do it for a short time, and you see very few other people doing it. So, likely response header, and yeah, there's different ways you can set the response header. So I listed like the most typical ones here. And which one should you choose? Well, I think it depends on who's going to update your header and how quickly does it need to be updated. But maybe more importantly, does your CSP need to be dynamic? That would call for going to the right. And also, do you want your CSP to be in your tests, in your dev and test environment? That should also push it to the right. Now, these are the ways that you set a header. But now I'll show you a different way of setting a header, which you may or may not know about, which is very good when you're starting to develop a policy. So let's work with the NDC Security webpage, the tickets page. And if you are in a Chromium browser, which you need for this, there is something here. Might be hard to see the tooltip, but it says override header. And if you click this, well, the very first time you might have to define the folder and accept that folder to be used. Yeah, but yeah, you'll get through that. Then you get this add header. You can modify one of these headers, or you can add another header. So what I'll do here is I will start typing content security policy. And if I make any mistakes, just call it out immediately if you can. You don't need to spend time on debugging. So I'll start with a very strict CSP. Default source, none. Now we'll reload the page, and we get the 1996 feeling. Really killed our web page, which is too bad. So we'll need to allow a few more sources. Now, when we started overriding headers, Chrome created this file inside a folder with the host. So it's this headers file. So first, I'll just make sure I have this copied. And here is, we can work in this file. Instead of having to go into the network tab and find the header, just work in this file. It's so much easier. You can just flip the windows back and forth. So now I say that in addition to default source none, we accept the same origin for images, scripts, styles, fonts, and connect. That's like data sending and receiving. So we'll save that one, and then we'll reload the page. And did I tell you that you can kill your page with CSP? You can kill it big time. So we need to save it, and my experience tells me that this is because some script is trying to access some style which is blocked. Maybe I should even try to take a look at that. Let's look at in the console. Refuse to apply inline style. I bet there could be more of those. Yeah. Okay, I'll make this bigger. Refuse to apply inline style. So let's add, where was I? Unsafe inline. And let's see if something works better. Oh, it's working a lot better. That's good. Still, we can't buy tickets anymore because there's a few more errors we need to resolve. So let's now just walk through the console errors. And we might have to do this, or we will have to do this iteratively. Because once we, for instance, allow this script, guess what? Another script will run. And then another script maybe, or it'll try to send data somewhere. So the browser is very kind, and it's telling us that there's an inline script, and here's a hash that will allow this script to run, because it's a hash of that script. So I will add that here. And here's another one. This is a rabbit hole. I can add this one, then I immediately, next round, have to add 4 more hosts. And I don't know what this is for. And you should make the same, ask the same question when you're working with this, do we really need this? Because this appeared on the page 2 or 3 weeks ago. I have no clue what it's for. So we'll skip it because it will take too much time. Refuse to load image. So we'll just scroll down and see if they're all the same host. They are. So we'll just take the host, and we'll say that for image source, which is here, we allow all images from that host. And then a few more here. using Sentry, probably for some statistics or something. So we'll allow to connect to Sentry. And they're connecting to Sanity, which seems to be the CDN. That's at least where all the images came from. So they probably one of their favorite services. And another script. This is for the tickets, registration checkin.no. So I will add that to script source. And just to save some time, I will also add it to style source, because that will come on the next one if I don't do it now. So that's faster. OK, let's see what happens. First, Google Tag Manager. I'll come back to that one in a minute. The rabbit hole, skip that one. Refuse to connect to static checkin.no, static checkin.no, logging checkin.no. I'm surprised, not app checkin.no yet. OK, oh, there it is, app.checkin.no. So 3 different subdomains of checkin.no. I will do that in the simple way and doing the wildcard. So wildcards, let's talk about them. So what I'm doing now, I'm using the asterisk from checkin.no. That will allow any subdomain like API and logging and what was the other one? Yeah, doesn't matter. But it will also allow any like number of subdomains deep. This will not allow checkin.no. So if you use the wildcard dot something, it will not do the main domain. And of course, if you think about the security implications, we can't have checkin.wildcard. But we can use wildcards for ports. And if you just use the wildcard, you need to remember that it is a host wildcard. It's not a scheme wildcard. So some people will say that, well, if you want to allow anything, just insert the asterisk. No, does not work that way. And yeah, we might even see an example here soon. It's a host, so it's not all schemes. So if there's something loaded on a different scheme, it won't load. For paths, because you can also be strict and specify a path, like the wildcard character is really the slash. So if you end with a slash, it's like everything inside that folder. If you don't end with a slash, it's that specific file. So did we save? Let me check. Yes, we saved. Now, does it load? Yeah, it's loading. So we're getting somewhere. But first, Google Tag Manager. This is very common. So I'll cover it a bit more. If you run into Google Tag Manager, you can refer to this page. And by the way, all the resource URLs will be on the final slide. So you don't need to take pictures if you don't want to along the way. This page is very useful. Google has documented it well, how you need to work with Google Tag Manager in case you use Google Analytics or Google Signal or yeah, what they're all called. For instance, how to insert the nonce to work with that. And further down, if you use, let's see, if you're in preview mode, then you need to implement these 4 directives with these sources. If you use Google Analytics, it's 3 directives and some sources. But if you use Google Analytics with Google Signals, then you need all of this. So it's a bit more. Then you have to note the last one here, the Google TLD. And if you want to support this around the globe, you will need a lot of different Google domains. They're actually listed here just for convenience, the supported domains. Let's make it a bit bigger. I don't know where you would need Google Cat, but it's 187 different ones. So you might not want to add every single one. Well, depending on if your service is only in one country, you might only need that one. But also note, it's for image source, but it's also in connect source. So if you want to support it all over the place, 304 hosts to put into your CSP. It's going to be huge. So if you see Google Tag Manager, do it that way. So this is not CSP related. Oh, it's good. it's not CSP related. Oh, refused to load, that's CSP related. And here it's the data URL. So you should not use data URLs for scripts, but for images, it's not that big of a problem. So let's add it here. And if you wonder what it does, what we're missing, it's the plus and minus here. That's coming from that data URL. The rest seems to be OK. So now let's see if we get the plus and minus. I think we're done. You can, of course, check that the scripts work. Does the menu work? Yes. Can we book tickets? Yes, we can book tickets. So yeah, that's how we can build a policy. And now let's take our policy. Take all of it, and we can go to the CSP evaluator, also from Google. This is actually one of the few parsers that can actually parse it well and say something sensible about how good is this thing really. So I just paste it in here, and that will immediately get the results below. So it says for the different directives that most of them are good. It says it's missing required trusted types for. That's one of the experimental ones. So yeah, we didn't do anything about that. Script source, we can expand. And it's saying all good for the hash, which is one specific script. For the other ones, it's I can't really know. Because there could be bypasses. There are some bypasses. And it's mentioning them here. It's self can be problematic if you host JSON-P. Because JSON-P endpoints can often reflect script back. So it's a way of just running script. Old AngularJS libraries are a known bypass. User-uploaded files are, of course, bad, or could be bad, or could suddenly change. Yeah, so it's pretty much the same on registration check-in.no. So you saw a hash. I grabbed the hash from the console. That was the hash of an inline script. So sometimes it's really easy. You can just grab it, but you shouldn't have a lot of hashes, because you'll probably forget which hash correlates to which script, and suddenly you end up, our scripts changed, and now we don't know which hashes we can remove and which should be added. Oh, frustrating. And sometimes the scripts are dynamic, and then you'll need to calculate it. And this is how you do it in case you need it. Can be done in a few lines of code. Just take everything that's between the tags, including white space, find UTF-8 representation, hash it, base64 encode it, and put it into your policy. So that's the inline stuff. If there's a file, what you do, well, most people will tell you, download the file and run some hashing tool, or you can just be lazy. You can set an integrity attribute, a dummy one, on the script file that you're downloading or loading on your page. And the browser will very kindly tell you what the right one is when you present it with the wrong one. So this is one way that we can allow scripts and styles. Another way we can allow scripts and styles is a nonce. So a nonce is just a random value. You add it to the relevant directive, like default source or a script or style directive. And then you set that nonce as an attribute for the styles and the scripts. And these have their pros and cons. Let's dive into some more details. For a nonce, you need one for each page load. So caching could cause some trouble here. For the hash, you'll need one for each distinct script. So there could be a lot of them if that's the option you choose. And for NDC Security, for all the inline styles, if you didn't want to rewrite them, I think nonce would be really good, because otherwise you would have 20 hashes for really small, likely small inline styles. But the hash will need to be recalculated if it's dynamic. Nonces only work for tags, not for attributes. Hashes also only work for tags unless you add unsafe hashes. And why is that unsafe? Well, it's like an attribute. It could easily be run out of the expected order, like doing a transaction where you don't expect a transaction, stuff like that. So what I have shown you is like a host-based way of allowing different sources, where we did the keyword self. We could do example.com. We could do as you saw, we had different host names, and that was how we built most of the directives. I didn't show nonce, but I just talked about it, showed you a hash. So these are different ways you can do it. But then there's also a totally different way of approaching this for scripts. This is scripts only, and that's using the keyword strict dynamic. If you add this keyword, and it's a CSP level 3 browser, which all of them are now, it will disregard self and all the hosts and all the schemes and just work with nonces and scripts. And why would you do that? Well, it could be that you don't really trust like the sources, like a host, because you know there is a JSONP endpoint, or you know there is like on the same host we serve client scripts. Then you can say, well, only the scripts that we specifically allow with a nonce or a hash should be loaded. But the good thing here is that also all the scripts that they load themselves will also be allowed. So if you do it in the correct way in green, like you create an element, set it to a script, and append it to the DOM, that script will be included. It will be allowed. So, but don't write another script tag, because that won't be allowed. So, bit of a recap here. Different types of URLs and what's allowed. So, for most of the directives, except when we're working with scripts and styles, we're working with scheme source and host source, and mostly host source. And for a regular URL, like something on HTTPS, you see you can use all of these where applicable. When it comes to data URLs and blob URLs, it's a bit more restricted. We had some inline stuff, and what do you do about that? The best thing to do is to move it to a file, rewrite it if necessary, and then move it out to a file. And not work with at least a lot of inline styles and scripts. There is something you can do, as you see to the right here, you can do unsafe inline. And there's a reason it's called unsafe. And if you want to have a CSP protecting you from cross-site scripting, if you do unsafe inline, but also a data scheme, then you won't have any protection, really. You see Scott back here. He has written a blog post about, can you get pawned with CSS? Where he's arguing that for styles, it's not the same threat. There are some threats, but they are on a totally different level. It's not like scripts. So avoid unsafe inline for scripts, because you're just wasting your time writing a CSP, but allowing inline script. So if you set a script directive, it will by default block all inline style, but it will also block dynamic string evaluation. So if you have eval, new function, set timeout, set interval, and the first parameter is a string, it will try to evaluate that string and run it as code. And that is, of course, dangerous. So you should try to rewrite that code. But it's, of course, in some third party, so it's really hard. So you could do unsafe eval, but don't do it. There's also another unsafe related to this. It's WASM unsafe eval if you need to compile WebAssembly. Won't go into detail on that. So we want to prevent XSS But it turns out sometimes, or actually a lot of times, to be really hard. Mostly due to inline scripts, because there could be legacy code or frameworks that are inserting even dynamic inline scripts. Could be a nightmare. And you have a lot of third-party code which is not CSP compliant. There could also be eval in all of these types of code. You could have some really bad sources, just the sheer number or the trustworthiness. And you can have client content, which, do you want your clients to write arbitrary scripts? It's maybe not the best idea. And then you have your public web page, typically done by the marketing department. They have some CMS, like WordPress, a ton of plugins. None of that stuff is really CSP compliant. Top of that, they have, of course, like Google Analytics or some other analytics and trackers and whatnot. And trying to make a strict CSP top of that. I've tried a few times. It's just not possible. So I talked to these guys here from Tina, CMS today. Wanted to check how their CMS is. And it was pretty much the same experience as we saw with the NDC Security webpage. I think it's possible. I think they even put it on the backlog. So if you want security, go somewhere else than the marketing department, because people say you can't, you have to choose between usability and security. I think it's really marketing or security, because they're never in their specifications to have secure products. Sometimes also, but also it can be easy. If you have a single page application which isn't doing a lot of crazy stuff, and it's built with a modern framework, then it can be really easy. But it can also be hard if there suddenly is some payment page or whatever, because you only have one CSP, so you can't have different CSP for different pages, because it's a single page application. So it's all the same thing, all the same CSP. The other easy way is to have a content security policy from day one. I did this with a project. I was working with this in this development team. It was really my only contribution, because I was doing so much in security instead. And this was also security, of course. But it's still there. The developers, if you get the developers to respect your policy and work with it and not just tear it down once they run into some troubles with it, it might survive and actually save you from cross-site scripting. So I've been talking about the strict CSP and strict on cross-site scripting. What else do we need to do to be strict in general? Well, first of all, object source can run scripts. You will likely not doing it, so just set it to none, for instance, or self. If you don't use none or self, get that script into some safe place and run it from there. Style source, already mentioned that it's similar to script source in a lot of ways, but it's less powerful. So it's good to do it. Base URI, you're probably not using it, so I don't restrict it so that you can't load the relative URLs from some other host. Default source, that's where everything falls back. So if you want to prevent exfiltration in general, better implement it. And you can do as I did, start out with default source none or default source self. And then also the one, this is where people start. They implement frame ancestors to prevent clickjacking, or restrict framing as it can also be called. This is the same thing as X-frame options, which you probably know. This one is just more flexible because you can add hosts. So you can say that, well, there's a lot of sources that can actually frame this page. And now we're over in the gotcha section. So on the left, we see frame ancestors. It's where can your page be embedded? So it's ancestors, because that's the parent page. And this one has a fallback to X-frame options. So if you don't implement it, it's X-frame options instead, if you have that. If you implement it, X-frame options is ignored. But people confuse frame ancestors and frame source. So frame source is about a source on your page. So something that you want to frame or want to block possibility to frame. And this one has a fallback to default source. CSP sometimes gets confused with other headers. And yeah, for framing, it's the same thing pretty much, just more flexible in CSP. To prevent XSS, just mentioned, need to restrict script source and object source. Some people will say, yeah, but we use XSS protection. Well, the problem with that one is it's dead in all relevant browsers. Like, yeah, IE is not relevant anymore. Forcing HTTPS, we can do that on the current page with upgrading secure requests, or we can do it on the current host or domain with strict transport security. And we can also restrict data sharing, also on the current page in the browser, or we can regulate it with course headers on the server. So these are different, but they're kind of it's the same concept, but from different angles. Multiple policies is another gotcha, because there's a lot of people who want to enable a CSP, and in the process, they enable the default CSP and the one that they write themselves. Suddenly they have two policies. And it's the Swiss cheese model. All the content, or any content, needs to pass every single policy. If it fails on one of them, it's blocked. So for those implementing the default policy, it's typically very strict. And they try to add as many policies they can to allow something. Still doesn't work. Needs to pass every single one. There are use cases for multiple policies, and it's allowed and intended. So it's not like the last policy in the response. All of them will apply. Reporting. There are two reporting directives. It's report URI, where you set it to a URI or multiple URIs. And then you have report to, which is where you just mention report endpoint. Now, if you look at the state of these, it doesn't look too good, that they're deprecated or not supported everywhere. Yeah, if you want to be supported everywhere, you can do both of them, because there's a fallback, so you'll only get one report. But you'll probably be safe with report URI for a few more years, I would think. This is what a report looks like. So this is the data you get. So first of all, it's a document URI, and this was like the original URL, not the one after all the redirects. In this case, ndcsecurity.com. We get some info about loading that page, no refer, status code 200. And then we get the source file. This is very often the same as the document URI. But in this case, the violation of our policy came when Google Tag Manager script was trying to do something. And it was trying to send or receive some data from Google syndication.com. So that's what's blocked. Then we can see the original policy. That's also quite useful in case you have multiple policies, or in case you just updated your policy. You can see, is it the new or the old one? Is it still in the browser? Someone haven't reloaded. Then you get to know which directive. In CSP3, these values are the same, so there's like double information there. Disposition, is it enforced, or is it report only? And then you get some other neat information, line number and column number, to try to find where did it happen. Well, in our case, we could just see in the browser error, we could just click on the script. But if you get this from a user, it's really useful. You can also, in the relevant cases, get the script sample, the first 40 characters of the script or style, which lets you identify it quite easily. So I think reporting is great. On my blog, I just put out a piece about abusing CSP reporting, or being very creative, reporting on stuff which isn't really related to CSP at all. But when you develop, you can get a lot of feedback. I try to tell people, you can put your policy out there. You can get all the violation reports. You can understand how your policy is doing. If there is anything we've forgotten, it has no risk. It's like, no, we can't do that. Well, you can. Only the users that open dev tools will see the errors. Nobody else will see anything. everything will work just as before, but you will learn what happens when your policy is out there. You'll quickly learn about the problems if you monitor the reports. And same thing after you enforce the policy, you will know what's going on. Is there any problem? Do we need to fix anything? But of course, process. Who's going to monitor these reports? And what will the process be for changing code or policy if there is a real violation? Who's going to do that? So yeah, I still think reporting is great. There are some downsides, not to reporting, but there are some things you'll be missing. There are some directives that don't report anything. And then if you implement frame ancestors to find out who's framing us, my page is being framed somewhere. Sorry, privacy reasons, not telling you. Sorry. And then some query string parameters are also removed for privacy and security. So you'll get a lot of good feedback from the real users on what's going wrong. You only get what's going wrong when your app is there. But sometimes that's not your fault. And actually, you'll get a lot of noise. Sorry. So top one that I've seen is the Facebook in-app browser. So if someone is viewing it, you're viewing your web page or app inside the Facebook browser, it's trying to load some scripts. And there are some people who don't like the font you chose. They want to have their font, apparently. And you typically get like 20 of them at the same time. Like someone tried to load a font. Fonts aren't like super security critical. But yeah, sometimes you may not want to like be flushed with font source reports. Translation services, I see them once in a while. And they're a bit interesting because there might be users that want to translate your page. And do you want to block that or not? Depends on your threat model. You might want to allow all the translation services that you see because it could be useful for the users and the security trade-off might be okay. You also see browser extensions and you will see some sneaky stuff. People trying to modify your page. VPNs, malware, and even security products will try to do this. They'll inject stuff. And this is really interesting, but it's like noise. And some of the security products I've even seen tried to modify the policy, which is another very sneaky thing to do. So you'll get this noise, and you'll need to verify, is this due to the user and the user's environment, because they have like a extension that they installed, or they got some malware, or is it due to the app? So you might have to check it. The easy check is like, okay, is this like 1% of the users visiting that page? Or is it like all of them? Also tells you a lot. So now I will show you how not to make a policy. This is a real policy. It's only 2 directives. It's default source and it's script source. And if you wonder what it is, the 6th line might give something away. This is Zoom. From March 2020, if you remember, we all had to start working remote, and we all needed video conference services. So a lot of people started to use Zoom. And there were some security considerations that quickly came up and got a lot of attention. It was not the CSP, that was only for the very interested. But it was like the service in China and a few other things. But someone looked at the CSP, and I was able to find it. Yes, there's a bit of China here as well, zoomus.cn. So let's look at this policy, which is probably built in the manner, make things work. And, oh, we're getting these violation reports. Something is going wrong when our users are using our page. Let's fix that by amending the policy. And, okay, so if you look at the default source, what do they allow? Then this is like all the fetch directives except script source, like images, media, styles, fonts. Yes, they allow HTTPS, Safari extension, blob, data, and self. Now, what do they not allow? HTTP and WebSocket. Yeah, maybe a few other obscure things that's probably not relevant. But then you have script source. So they start out really bad. They allow unsafe eval and unsafe inline, and yeah, I don't know if blob maybe not that bad, but unsafe eval and unsafe inline. Yeah, it's pretty much ineffective. They wouldn't need to write all the other things here. But let's look at it. So they have some Google services, likely because they're using Google Tag Manager. Yeah, so they need to add this. So this is perfectly normal if there's a public web page. So there's a lot of things that are normal on public web page because, yeah, no marketing. Yeah, they want to track everything. So I highlighted those that I think could be relevant to a public web page. Like down right, you see YouTube. They probably need to load the script from YouTube to run the embedded YouTube video. Zendesk. What else? Tracking.g2crowd.com. Probably loading some scripts from JSDeliver and jQuery. Hotjar is a favorite one. Seen it a lot of times. Analytics services, trackers. So I don't know if all of these are on the page, but these are like normal, I would say. Like I've seen them on other like marketing web pages. And then wildcards for subdomains. A lot of those. There are something called subdomain takeover. There are risks with allowing a lot of subdomains. Yeah, I would rather list a number of different subdomains in script source. I would be more lazy in like an image or font or something like that, but for script, I would not do this. And then you have CDNs. Now, do you have control over what's in a CDN, a public one? Like, who can upload a script to Dropbox and make it load? There's no security in this. Okay, let's move on. Likely a browser extension. I'm not totally sure, but I think so. And to be sure, they added it twice. And they did the same with this security product, even right after each other. And then they have some other ones. Now, what are these for? I did some research into like similar reports at the same time, and I classified all of these as malicious. Like some of them you can go and look up, like 50million.club. Yeah, likely not a relevant source for really anyone. There are some things you could look at that would tell you this is malicious. You could try to download the script that was in the violation report. And sometimes you wouldn't be allowed to load it because they probably like snuck in some parameter or header or something that if you try to research this, you're not getting our script. Sorry. Like that was the first one, big red flag. Second one, you look at the script and you see they're trying to send data somewhere, but it's really hard to figure out because it's obfuscated. So you're obfuscating where you're trying to send data, or like the whole thing is just totally obfuscated. Yeah, malicious. Also tried with some of them to send them from one email provider to another one. And that script was blocked on the way as an email. Yeah, likely malicious. Yeah, they typically share IPs as well. So if you classify one or two of them as malicious, a few others can also easily be classified as malicious. So the point here is that when you're creating a CSP, it's not about like taking your page and then adjusting your CSP until the point where it matches your page. Like everything is allowed, even though it might have looked like that in my demo. When you're working with a CSP, the point is to make a strict CSP, and after that, what you might need to do is to make changes for your application or your website to work with that CSP. So that's the end. This is where you can take a picture if you want any of the resources. And I can take questions. Yes?
You mentioned that you saw some tools that were modifying was security software that was modifying the CSP on the client. Doesn't that sort of be the purpose?
So the question was, did you say that, or you mentioned that you saw security products?
You mentioned that.
Yes, yeah. So I'm just repeating your question so it will be on the tape. Now I really got out of it. Security products, did you say that they would also modify the CSP? Wouldn't that defeat the purpose? So this is actually something Zscaler has done. At least that's how I interpreted it. Because it seemed like it was actually changing it. Because you get the policy in the violation report. And it seemed like it had inserted Zscaler into every single directive. So it's kind of sneaky. And it defeats the purpose. I don't know why they need to do it that way. I don't really think you have security if that happens. Because what if Zscaler is hacked? And they start to inject whatever. Yes, back there.
Are there any front-end frameworks, popular, so to speak, that you know of that totally violates all CSP attempts? So you have to include unsafe everywhere?
So the question is, do I know about any front-end frameworks that like totally violates CSP? We have to like allow pretty much anything. Well, I think a lot of, especially old stuff, actually, it's a backend thing, like .NET, if you're really old versions. Maybe it was just something in our code, but it seemed like the old .NET was just inserting some dynamics inline scripts. I could have been wrong there. But I don't know about any, but there are some that are just doing a lot of stuff like injecting a lot of inline styles, which is like how a lot of people have done it, like style attributes. They could work with class names instead, but they chose to just add and remove attributes. I have no more details. Yes?
Performance hits like for having a massive CSP for massive policy in my code. Are there any performance issues or any best practices in terms of that?
So are there any performance issues with having a massive CSP? I think I'll need to ask Scott about that one.
The only thing I'd be worried about is the size of the data transfer and the header. And if you're using H2, you get HPAC compression, so probably not. The evaluation of the policy can't be measured.
So as Scott said, yeah, it's the data transfer. So it's probably doesn't take much longer in the browser. But of course, like what happens when your header gets very long? I actually had a case where I was emailing an updated header for our public web page. And the guy in IT was updating it. He or I accidentally cropped it. So a lot of things stopped working. And after that, I always put report URI at the very beginning of the CSP, not at the end, because it was also cropped off. So I didn't get any violation reports, which was, of course, stupid. So yeah, that's another one. Put the reporting directives first, so in case that strange thing happens. Other questions? Okay. I don't need to hold you here anymore. Thank you.